So hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So guys, as you know, we have started our new series based on the selection criteria of solenoid valves. So we have covered some of the important parameters which are required for the selection of solenoid valve. Today we will focus on one of the most important parameter, which is called as flow coefficient and denoted by kV or CV in the catalogs. And this is very important parameter while selecting a solenoid valve. So do watch the video up to end and don't forget to subscribe the channel and hit the bell icon for getting the updates of the upcoming videos. So without wasting time, let's get started. So what is the flow coefficient? This is the first question, like why it is important and what it is. So the flow coefficient measures the rate at which the fluid, it might be liquid or gas, can pass through the wall, right? So indirectly it indicates the wall size. So if you require a large flow rate, you have to go for a larger solenoid valve, or you must check the flow coefficient of the valve. We will see how this flow coefficient is correlated with the flow rate, right? So selecting the appropriate sized valve, ensuring that all the fluid can go through the desired pressure. So for that purpose, it is very important to select the proper CV or KV, that is nothing but the flow coefficient of the valve. You should check out for the flow coefficient value of the valve in the catalog. We will see that how to check that value in upcoming sessions, right? So valve flow coefficient variables. Now what are the variants on variables on which the coefficient is based on? That is the specific gravity. The specific gravity affects the density of the fluid flowing through the valve, and that's why it is very important whether you have a gas or a oil or liquid that affects the CV value. Then we have a flow rate. So flow rate is the amount of fluid that is actually passing through the water at a given time, right? So that is the flow rate. And then we have a pressure drop, right? The flow rate is important. So pressure drop, we have seen the types of valve, and we know that some valve require pressure differential, right? So we should know the pressure drop also, and that is an important parameter for calculation of CV also. Now let's check out the CV flow calculator. What is the correlation, how we can calculate the CV value? We know the variables, so let's check out the relation. So CV value is important factor for the correct wall sizing, right? So the pressure drop charts are also mentioned in the catalogs. We will check out those. Now let's check out the CV flow calculator. We have Q, desired flow rate, pressure differential, and the specific gravity, right? We have seen that. Now this formula will be different for say gas and liquid, so it will not be same, right? Because the liquids and gases have different properties, so the formula cannot be same. So let's check out the formula for liquids first. The CV value is equal to we can check out the flow rate under square root of Hg divided by dP, which means the CV is directly proportional to the flow rate, or CV can be calculated the help of flow rate, your Hg and dP, right? So we have seen what is Q, what is dP, what is Hg, right? So you can see that CV and Q values are directly proportional. So let's have an example. You can check out this example how the CV value has been calculated over here, right? And then the CV calculator for gases. The gases have different properties, so the coefficient depend on different things. You can check out the condition. If delta P is less than P1 by 2, the formula will be different, and if it is greater than the thing, the value will be different. You can check out what are the parameters over here. And again we have a example for gases also, that how to calculate the CV value. Right now, why this CV value is so important, uh, let's check out that why it is so important, right? So these are some of the parameters, like controllers. The wall may not be able to open or close fully, leading to the pressure drops or over pressurization. If you select a wrong CV value, a wrong wall, so this can happen, right? So it might not open fully or might not close fully. Then we have reduced efficiency if we select a wrong wall, if the requirement is for smaller wall, and if we select a bigger wall, the power consumption will be greater one and it will reduce the efficiency. The short term lifespan, over time the wall may experience increased wear and tear. Then the inconsistency in operation, then we have a cavitation if the wall is undersized, because of which there will be a higher pressure drop and there will be a phenomenon called as cavitation, and the wall will get damaged. So all these things are very important and all are interrelated. Then we have water hammer effect. If we select a improper wall, uh, then it will cause a problem. And what is CV and KV value? Both are the flow coefficients. The only difference is CV is expressed is in imperial units, that is the gallons or GPM, and CV KV is kind of metric unit. So KV is 0.857 times CV, or CV is 1.16 times of KV. So this is how these two things are related. Both KV and CV are same parameters, that is flow coefficient, expressed in different units. One is in metric, one is in imperial units, right? So let's check out the calculator. We have the readily available calculator over here. Liquid, you can see the liquid options are available: glycerin, gasoline, and many other things. You can put your own user defined value also, and you have to put the specific gravity accordingly. Let's select water, so it will show the by default specific gravity. You have to mention the inlet pressure. Let's select the inlet pressure as 10, and then we can select units whatever it may be. Outlet pressure, let's select the outlet pressure, let's say 15. If you select a 15, what will happen? Let's check out. If we select a value of outlet pressure greater than inlet pressure, what will happen? So it is not possible. Primary pressure must be higher, because there will be losses, there will be pressure drop. So it is not possible to have a higher pressure. So let's select 9, and flow rate is 20. So let's check out what we have. The KV value is 20 and the CV value is 23.12. Now let's check out for a gas. We have again different kind of gases available over here, having their own properties. Air we have selected. Let's select the air temperature. The inlet pressure, let's select 5. The outlet pressure, let's select say 4 bar, and the flow rate, let's select 30. So what, let's say 30 gallons per hour, or 5 gallons per hour. Calculate. So KV value is this much. So you can use these calculators directly, which are available. I will drop a link in the comment section. So this is how the CV value is important, and we can calculate the CV value. It is different for different gases, different fluids, then it is different for a liquid and then the gas also, right? You can see the KV and CV values, right? You will get both the values in a single calculator. So this is all about the flow coefficient of the solenoid valve, the CV value, its importance, and this is it. So this is it, guys, for our today's session, and I hope you liked the video, and if you have any doubts, please do write into the comment section. Until then, keep intro making, and thank you for the patient listening. Thank you.